Hey everyone, this is FixReef, and today we have another EB832 for repair. I'm sure you're sick and tired of seeing this in the video stream, but they clearly have all kinds of problems that are interesting to dig into and find out. So this one is going to be different from all the other ones that I had in the past. So far, the symptom of this EB832 is that it kind of communicates to the head unit, but at the same time it doesn't. The head unit can see the EB832 connected sometimes, not every time, but whenever, even if it's connected to the head unit, you cannot control EB832 from the head unit. So if not for the communication puzzle, you would think that the problem is once again with the 12-volt power supply. And it probably is there somewhere, but the communication problem is the primary issue. I have recently discussed a similar problem with somebody else who asked for my help diagnosing their EB832, and the symptoms were very similar. It kind of connects to the head unit, but it does not. It cannot be controlled, but it kind of shows up in modules. It's kind of there, but at the same time it's not. And my response to that person was that the CAN transceiver is likely bad. And I suspect that that's the case here as well. But what's interesting about this repair is that it's not a binary type of situation where it just does not connect, does not talk to the head unit because the CAN transceiver is blown. It's something in between. It sometimes connects and sometimes it does not. So let's find out what's going on. I just removed the screws here. So what's left is just open it up and see what's inside. The cables for the LED panel is disconnected. I wonder if someone was already here before. Let's see what we have. Before I completely take it apart, as usual, I'm going to plug it in and check the status LEDs on both power supplies. All right, so the 24-volt power supply is working. At least it's on. The 12-volt power supply is also on. You can see the 12-volt. You can see the red LED on the 12-volt power supply. But clearly, the 12-volt power supply is the type that fails often. So I'm not quite sure what if that's going to be part of the problem. It should not be a part of the issue, with the communication. But either way, if I end up fixing this EB832, I will likely have to also upgrade the capacitors on this power supply. All right, so far so good, nothing out of the ordinary. Let's unplug and start taking it apart. All right, first let's do a quick visual inspection of the back of this board. Doesn't, from this on the surface, doesn't look too bad. I'm looking for discoloration, for any type of sign of issues with components blown. I'm not seeing that much yet. This is our CAN transceiver over here. I can't quite see without the microscope, but for now it looks fairly good. The buck converter is still there and it's all right. Yeah, it doesn't look too bad. So a lot of things are pointing towards the CAN transceiver at this point. Let's take a closer look under the microscope, just to make sure that we're not missing anything of substance. Okay, hopefully you can see what I see. So this is again the CAN transceiver. I'm not seeing any holes. There is a bit of oxidation on the pins. Not a whole lot, nothing that would short things quite yet. So I'm not seeing anything particularly bad. This is a little bit off, but it looks like it's connected. I'll probably reflow this if I get to work to fix this. The buck converter also okay. Huh, look at this. I've been seeing things like this before. This isn't factory. At least I don't believe this is factory. So I suspect that this is some type of a refurb from Neptune with this kind of workmanship. Bit more corrosion, but nothing too crazy, nothing that can't be cleaned up. Let's check both controllers. This controller looks real nice, nothing I can see here. This one also looks pretty good. What the heck is this? See this? So these are the two pins, the two wires rather, that come into the 24-volt power supply. Actually go into the 24-volt power supply. This is the AC, this is high voltage line. One of the two pins is almost completely disconnected from it. The 24-volt power supply still works, but this is wrong. I think that this is a refurb from Neptune. Unless somebody else tried to fix this before me, who is not Neptune. I think there is a mess here. Okay, well, all of this needs to be fixed. But I am not seeing anything else wrong. Okay, so before we move on, let me just show what I'm talking about with regards to this 110-volt wires coming in to the 24-volt power supply. You can see that one of them is properly soldered and it looks clean. The other one came out almost entirely, held in by a thread with the hole that you can see through. This is nuts. All right, we'll fix that. All right, so what I propose we do, again, in my typical repairs, I would just attempt to replace the CAN transceiver. Once again, there is no, as I've mentioned to the other person who had a similar problem, there is absolutely nothing in between the data pins that come through the Aquabus or USB ports and this CAN transceiver. If there is a problem with the communication, it's more than likely it's the CAN transceiver. There is nothing that can go wrong from the data pins to the CAN transceiver. So more than likely it's this problem. But because this is such an intermittent connectivity issue, it's interesting to take a look at the data that comes on these pins and see what we actually get, because clearly some data makes it through to the controller and some data does not. So there is some type of corruption or error that occurs, probably on the CAN transceiver side, that does not allow this unit to correctly connect and communicate with the head unit. So to verify the theory, we're going to connect this harness that I've shown in previous videos that goes to my logic analyzer so that I can see the actual data coming into the unit. To do so, let's just say that black is going to be our ground. Then let's just say that this white and gray are going to be the serial side, and red and blue are going to be the CAN side. Let's connect them all under the microscope, as everything is so super tiny. All right, before we do anything else, let's add a little bit of solder to the pins that we're going to connect to, because we'll be adding wires. So I'm working on the serial side right now, and then the CAN side. Okay. Okay, let's just say that this is going to be our data lines. Okay, let's connect the data line first in a sequence and away from other pins. Nothing has to be pretty. This is just for testing purposes. One day I will get myself a nice set of micro grabbers so that I can just hook up to the pins without soldering. And now the can side. Now I understand why I had to put a blob of solder everywhere, because the distances are not perfect and I don't want to be stretching anything, and I don't really care about extra solder at this point. Everything's going to be cleaned up before it's ready to go, and chances are this whole can transceiver will be gone soon enough, because more than likely it's damaged. Okay, so now that the unit is connected, I'm going to plug it in and I'm going to record the communication between the head unit and the EB832 and see what we get. Let's record a bit. It's definitely zoomed out quite a bit. Okay. All right, so there is definitely some type of activity going on. I can see communication on the CAN side. It means that EB832 is receiving requests from the head unit. I see it being translated to the serial side so that EB832 can understand what's going on. And I see that every once in a while, EB832 actually sends the data back. So what we are going to do now is we're going to replace the transceiver and see if we will get the same type of output. All right, first remove all of the ugly wiring. I will use my hot air to replace this. Add some flux. We already have quite a bit of leaded solder on it, so that we don't have to worry about high melting temperatures. Well, actually, let's add some leaded solder to the pins that we didn't properly fix before. So I think that this pin's missing some, and this pin is missing some of it, and maybe this pin as well. Good enough. We'll clean up the area a bit, get rid of all of that mixed solder, excess solder for that matter, and anything else that does not look good here. Let's retune the pads. because I'm not going to use any more solder and have to add a little bit of flux everywhere so that allows things to flow properly. And here's our brand new controller. This is an extremely hard to find commodity this year due to the pandemic and chip shortages. Part of the reason why car manufacturers are struggling. Luckily, I have a nice stash of this. This one pin over here is not going to flow as well because of all of the copper around it. Okay, making sure that everything is properly seated. I will add some more solder just in case later to make sure that there is enough connectivity in a minute. Let's just run through with the hot iron to make sure that everything's got proper connection. That looks real good. Okay, before we wrap this up, I'm going to reconnect my wires. Once again, it's probably going to be extremely ugly. I'll start with the serial side. Okay, this is looking half decent, or at least functional. Now let's capture what we get out of this EB832. Okay, now let's find out whether or not we're going to get any data that's going to be different on this communication with the new CAN transceiver. Start capturing. As you can see, the data on the CAN and RX is still valid. TX data is currently gone, which kind of concerns me. And there is nothing on the CAN R anymore. So that's the difference. Problem is that right now this EB832 is connected to the old head unit. It's connected to the old Apex, not 2016. So the old Apex does not recognize the new EB832. However, when you connect EB832 to an old Apex, it does recognize it as an unknown module, assuming there is proper communication. And in my testing right now, finally, it recognized this module. So there is hope. I'm going to verify that it's working on a new head unit shortly. But for now, let's go back to EB832 and let's fix up all of the remaining problems that we found on it. First of all, let's remove the test harness and clean up this area. Okay, this is nice and clean, looks brand new. Next, I would like to put back in place a couple of these transistors that got butchered by whoever worked on this previously. First, this guy. And next, this. I'm really not very comfortable how this resistor is sitting. because I have no idea if it's properly touching the pads under it. This looks much, much better. Finally, and this I'm going to do not under the microscope, let's clean out this high voltage line. So the idea is that we heat this up real well, and hopefully we can push it in. To help me with this, I'm just going to add a little bit of leaded solder. Let's see if this will push through. Of course it will. That's all we need to do. It's all done. So behind the camera, I tested this EB832 for connectivity to the Apex 2016, and it works great. Absolutely no issues. It gets recognized right away. It communicates. All of the outlets work on command. Everything works perfectly. So what this tells me is that there was a problem, clearly, with the CAN transceiver again. Although the CAN transceiver had no signs of damage, it wasn't burned, there is no discoloration, there are no holes around it or on it. The testing that we did suggested that there is probably some kind of a intermediate short on the inside of the unit, because all of a sudden we were getting signals on our CAN R, I believe, and something as well on TX. And when we've replaced the transceiver, we were not getting anything on TX, and we were not getting anything on CAN R. So this means that the proper operating state of this is what we saw in the last capture of the logic analyzer. What this tells me is that the issue is not always on the surface. When you have intermediate connectivity problems like this unit or another reefer who I was talking to previously, it's more than likely the CAN transceiver that's causing the problem. And it doesn't have to be binary, it doesn't have to be either it's working or it's not working. It doesn't have to be visual where there is a damage on the chip. But more than likely the problem is with the transceiver. Once again, I suspect that I've seen a high number of these failures previously. Not as high as the 12-volt power supply on EB832, but it is up there as well. There is no protection between the USB Aquabus port and the CAN pins coming in, while on the same port we are carrying 12 volt. If somewhere in the chain this 12 volt is shorted to the 3.3 volt controller, it's likely going to cause damage internally, even if it's a brief short. So replacing this CAN transceiver fixed our problem. We also fixed issues that we saw previously with a couple of components here. And a problem, a safety really problem, with the AC pin not fully soldered in. Imagine if, due to some vibration or due to some handling, this pin comes off. When it's plugged in, this has live 110 AC voltage. It shorts to something else, it may cause a fire. I do not know the history of this unit previously. I don't know if this was a repair that was done by a reefer, or this is, or more than likely it's a repair done by Neptune through their refurbished units exchange. But this is not the way you do things. So I am happy that this unit is now working and this unit is now safe to operate as well. I'm going to also do a few more upgrades on this unit. I'm going to upgrade at least this 12-volt power supply, a few more things if I need to, and it will go back in operation. And with that, this EB832 is going to be happy again. If you enjoyed this video, please like and subscribe, and I will see you next time.